Today we're going to discuss the first four conceptual questions of chapter 3. These four questions are related with the topics that we have already studied till the third law of motion, right? So हम लोग discuss करते हैं. The first question is that why does dust fly off when a hanging carpet is beaten with a stick, right? So let's suppose I have a carpet over here. Okay, usually हम लोग ये काम करते हैं that whenever we want to clean up our carpets, हम उसे vertically hang करते हैं and उसको stick से थोड़ा सा beat करते हैं so that all the dust would fly off. So how does that happen? Right, whenever we beat that carpet with a stick, we actually move that carpet with our stick with such a high velocity. Okay, we provide force with the stick, and due to that force the carpet moves suddenly in a certain direction. So बहुत तेजी के साथ आपका carpet एक sudden direction में move हो जाता है, but the dust particles that are struck in that carpet are actually at rest, and due to inertia those particles try to stay at this in the state of rest. ठीक है, डस्ट पार्टिकल्स क्या करेंगे, वो उसी पोजीशन में रहें लेकिन हम अपनी स्टिक से कारपेट को मूव करेंगे. सो इन दैट केस कारपेट आपका डिस्प्लेस हो जाएगा, बट द डस्ट पार्टिकल्स, यहाँ पर मैंने ग्रीन कलर से डस्ट पार्टिकल्स बनाए. सो डस्ट पार्टिकल्स विल ट्राई टू स्टे इन द सेम स्टेट ऑफ रेस्ट ड्यू टू इनर्शिया. सो आपका कारपेट उस प्लेस से हट जाएगा, डस्ट पार्टिकल्स कारपेट से अलग हो जाएंगे एंड इवेंचुअली ड्यू टू ग्रेविटी दे विल फॉल टू द ग्राउंड. Okay, and they will be separated from the carpet. So that is the basic reason the carpet is set into motion by the stick while the dust particles stay at rest due to inertia. The second question is that if your hands are wet and no towel is handy, you can remove some of the excess water by shaking them. Why does this work? Actually, आप लोगों ने usually ये काम किया होगा. If you're if you don't really have a towel at that moment, and you can just shake off your hands like this, and all the water droplets would come off of your hands. Okay, so how does this happen? Let's suppose I've drawn some wet hands over here, and the green color shows the water droplets. In this case the water droplets are just stuck to the hand, but whenever I just start to shake the hands vigorously, बहुत तेजी के साथ hands को shake करती हूँ, then क्या होगा, मेरे hands एकदम से एक sudden motion में आ जाएंगे, बहुत ज़्यादा velocity हो जाएगी hands की. ड्यू टू दैट जो वाटर ड्रॉपलेट्स हैं, ऑफ कोर्स दीज वर एट रेस्ट, वाटर ड्रॉपलेट्स तो पहले रेस्ट में थे एंड दे विल ट्राई टू स्टे एट रेस्ट. इस वजह से आपके हैंड्स मूव करेंगे बट द वाटर ड्रॉपलेट will get separated by the hand because the water droplets wants to stay at rest due to inertia, and that is how the droplets and the hands will get separated and the water droplets will actually of course fall to the ground. The hands move but the water droplets stay stationary due to inertia. The third question is that why a balloon filled with air move forward when its air is released. Okay, so in this case this is a really common practice आप लोगों ने किया भी होगा. If you could just inflate a balloon, of course जब भी आप एक balloon को inflate करते हैं उसके अंदर air होती है and of course उसकी rubber की outer layer उसकी walls पर होती है. Okay, in this case जैसे ही आप उसे पकड़ के रखते हैं, if you could just take that inflated balloon and keep it pinched, in this stage the balloon is at rest. Okay, the air is inside the balloon and balloon is at rest. यहाँ पर मैं momentum भी discuss करूँगी, although आप लोगों ने अपने online classes में momentum discuss नहीं किया, but जब आप ये video बाद में देखेंगे then you will get the hang of it. In this case the total momentum of this whole balloon is also zero. Okay, because in this case the mass multiplied by velocity, their product is the same throughout. So in this case, the total momentum is 0 and your object is at rest. Okay, जब भी आपका object rest में होता है then of course उसका momentum 0 होता है. बट जैसे ही आप उस पिंच को ओपन करते हैं एंड उसके नोजल से एयर को बाहर आने देते हैं, देन ऑफ कोर्स यू विल नोटिस दैट after the air starts just flowing out of that balloon, the balloon would start to go in the opposite direction. Why does this happen? Because you can see that the air is rushing out in a certain direction. Okay, air rush out कर रही है, of course rush करने के लिए एक force apply कर रही है balloon पे. Then in turn the balloon would also apply some force on that on the air. So the air rushing out of the balloon is the action, and the balloon moving in the opposite direction is the reaction. So both are equal in magnitude, but the motion of air and the motion of balloon are in opposite direction. In this case, how does this happen? Because whenever the air rushes out of the balloon, the momentum is greater. Okay, यहाँ पर because हमने दो reasonings देनी है. The first reasoning is understandable for you because that's the third law of motion. Air एक side से बाहर आएगी, force apply करेगी, एक side से बाहर आएगी, of course. And दूसरी side से as a reaction, balloon भी travel करना start करेगा in the opposite direction. Now comes to the concept of momentum. Whenever one part of system or one part of, you can say, जो भी आपके पास object है, one part of that object or one part of that system, हम कभी कभी इसे system भी कहते हैं, the system actually travels with higher speed, then the other part also travels with that same speed in the opposite direction. So in this case यहाँ पर momentum ज़्यादा है. क्या मतलब है इसका मतलब है यहाँ पर जो भी आपका mass है उसकी velocity ज़्यादा है. Okay, then ये ज़रूरी है by the law of momentum, law of conservation of momentum, या आप आगे चल के पढ़ेंगे, that this part should also move with the same velocity in the opposite direction. ठीक है, so अगर एक part के पास कोई velocity attain हो गई है, वो किसी certain direction में move कर रहा है, then दूसरा जो part होगा वो भी उसी velocity के साथ लेकिन opposite direction में move करेगा. So here the momentum is greater. So in order to in order for the law of conservation of momentum to stay consistent, the momentum of this part should also be greater. So ये ज़रूरी है कि अगर यहाँ पर momentum greater है then of course यहाँ पर भी greater होगा. Momentum greater होने का मतलब क्या है? इस part के पास भी उतनी ही velocity हो जाएगी जितनी इस part के पास, इस air वाले part के पास है. So your balloon would also start to travel with the same velocity but in the opposite direction. The question 4 is also just very similar to the question number 3, and that is, why does a hose pipe tend to move backwards when the fireman directs a powerful stream of water towards a fire? Okay, let's suppose there is a fire in any building, and of course आपने देखा होगा जो firemen होते हैं वो क्या करते हैं, they would just go near that fire and open up that water hose. So इससे होता क्या है, they will suddenly feel a backward push. Why? Because the water that is coming out of the hose is actually the action, okay, that is performing. So this is the action, and as a reaction, the other part of the system or the other part of the object, which is just the water pipe, that water pipe will just try to go in the opposite direction with the same force. So in both the cases force is the same, but they both are acting in opposite direction. The water is coming in the forward direction and the hose or the pipe is going in the backward direction. The water that is coming out of the hose is the action, and the backward pull of the pipe is the reaction. Of course जब आप अपने hose को या उस tap को बंद रखेंगे, in that case the momentum would be 0 because there is no motion. जैसे ही आप अपने होस्ट को ओपन करते हैं, इट मीन्स दैट नाउ वाटर इज़ रशिंग आउट विद अ ग्रेटर स्पीड. सो इस पार्ट की स्पीड ज़्यादा हो जाएगी. इट मीन्स मोमेंटम ज़्यादा हो जाएगा. जैसे ही इस पार्ट का मोमेंटम ज़्यादा होगा, देन ऑफ कोर्स जो नेक्स्ट पार्ट है, जो प्रीवियस पार्ट है, उसका मोमेंटम भी ज़्यादा होगा. कैसे? बिकॉज उस पार्ट की स्पीड भी एग्जैक्टली उतनी हो जाएगी जितनी फर्स्ट पार्ट की है. सो अगर वाटर स्पीड अटेन करता है, देन ये पार्ट भी स्पीड अटेन करेगा, बट इन द ऑपोजिट डायरेक्शन टू कीप द मोमेंटम कंजर्व्ड. अगर एक पार्ट का जितना मोमेंटम है, देन दूसरे पार्ट का भी मोमेंटम उतना ही होगा. यानी दोनों पार्ट्स की वेलोसिटी सेम होगी, बट इन दी opposite direction. So these were the four questions that were related with your topic that we have studied recently. I will discuss the next conceptual questions, but after studying